Okay, antiderivatives, part B. We have, okay, if I gave you that function there, yeah? What is the derivative? Thank you for putting the negative on there. Okay. So if I asked you to calculate the antiderivative of sine x, yeah, negative cosine, because you have to deal with that, right? We're going backwards, so yeah, because there's no negative on the sign here, you have to put it on the cosine when you go backwards. All right, so, but we're missing something here. Thank you. Okay, I will teach you how to deal with that tomorrow, and it will be a rare occurrence after that. Because you are integrating with respect to x, taking the antiderivative with respect to x. I shouldn't have said integrate, sorry. If that was a y and it said dx, it causes issues. So we want those to match, and they will. Okay.
For now?
No. Forever.
Okay, good. I hate when that happens.
Okay, good. So, the derivative of sine is cosine. Okay, glad you have that one down. So the integral antiderivative of cosine is sine. Yeah, so the antiderivative of cosine x is sine x plus c. Okay. Sorry, BC, we're working on different techniques of integration, and it just slips out because I see the sign. That's what we're going to call them eventually, yes. Okay, so you're okay with sine and cosine. What if I gave you the antiderivative, or calculate the antiderivative of secant squared? It's tangent, because the derivative of tan is secant squared, right? So all those 6 pairs that we talked about, be able to go backwards and the antiderivative, okay? So you'll have those 6 antiderivatives in your melons, right? I want to show you how to deal with something here. What if I asked you to calculate the antiderivative of cosine 2x plus 3?
Is it like the reverse change?
Yeah, that's what we're talking about here. That's exactly what it is. So what's the antiderivative of cosine? Okay, so we have negative sine. Okay, good. Thank you for clarifying, because I was going to go with it. Right? But we're missing something right here. Hey, think, you got to, on these ones you have to think backwards. What is the derivative of this? Of sine? Cosine. Copy inside, and then you have to derivative inside, right? The chain rule times 2. Okay, so calculate, okay, let's say, this will probably make it more clear, right? And we can throw the plus c out there. What's the derivative of that? Cosine times 2. See that? No Estaki. How do I deal with it right here? You have to put a 1/2 out here. Okay. See if I have a 1/2 out here? When I multiply by 2, what does that become? The number I need. So let's try it now.
Well, this is really not. I'm
Okay, what's the derivative of this? Cosine, right? Times 2. See that number? Now it matches that number. Okay, so you kind of have to go backwards on the chain rule a little bit. You're dividing by the derivative of the inside. Yes. It's kind of like the power rule, I guess you could think of it that way if you want to. Remember the power rule, you add 1 and divide by that number? Here you have to divide by this number. So, and you can get this pattern, it's the same every time. So if I asked you, what is the antiderivative of sine 3x? It would be 1/3 negative cosine 3x plus a constant. Okay.
Wait, why is it negative? Isn't that just
Because when you're doing it,
The derivative of sine is cosine, not negative cosine.
So why do we have the negative 1/3?
Because it's an antiderivative, and we have to deal with this.
I'm so confused. Negative cosine
Not good.
derivative of sine.
Okay.
that's what.
That's what the 1/3.
Why wouldn't it be like x2?
Because it's not, it's 3x. We don't have to take an integral of the inside, or the antiderivative. Okay. What we have to have is this, so that when we go backwards, it becomes this, right? Yeah? So if I calculate the derivative of cosine, it's negative sine times a negative, right? 3x, and then what's the derivative of the inside? It's the chain rule, 3. The 3 times 1/3 is 1. That's why we have to do that.
But you can just add in a number when you feel like it.
Like here?
So 1/3, you can just add it in there.
Well, if you need it. Right, exactly. So, is that okay?
Is it okay if you like get that power and then help yourself think about it? Right, sine of 3x is x sine. So
You can write that, yeah. So if you're confused, all you need to remember is if there's something in here besides an x,
I say you have to.
divide by that number.
Okay, that
Good,
actually,
okay.
that's.
That's kind of how your book actually presents it.
Well, what if I have
Right.
that?
Okay. So you're dealing with stuff in the middle, inside the function. So like reversing the chain rule.
So basically, instead of multiplying what's on the inside, like
You're dividing it. Yeah, that's a great way to think about it. So in the chain rule, this is Jablonski special here. In the chain rule, you multiply by the derivative of the inside, right? Well, in an antiderivative, you're going to divide by the derivative of what's inside. So see how they're inverses there. Okay, thank you. That's good. All right. Okay, I'm going to give you the most difficult one of them all. Any guesses? Yeah, thank you. Okay, E is for easy, right? Yep. Mm-hmm.
Okay.
So e to the x is the same antiderivative, same derivative, right? You go both ways, it's the same thing. Okay,
Okay.
so
Okay.
pay attention to that. Now, again, how do I deal with something like this? It's the same as sine and cosine. You copy it and divide by the derivative of the exponent. Okay.
Could you just do? No, never.
Okay, what's the derivative of this? Okay, copy it and then multiply by 3. Those cancel, right? See how they match? That's what you're looking for. So if you need, like I said, Friday, if you need to check it, you can calculate the derivative. They should match. Okay, so it's a good way to check. All right. So we've done the power rule. And we've done natural logs, right? And we've done cosine and sine. And we've done e to the x. Let me see if you can get this one. Ready, set, go. Yeah, it's a 7. It's just a constant. Multiplied, so you just leave it.
So if there's a constant number ahead of it, you just leave it? Wait, why would it be 12? Because e is a number, not a variable. So it's like 12 times. But why would it not be just, I thought it was 4.
What's the derivative of 4? 0. So the difference between, again, if a constant is multiplied by a function, it stays in the derivative. If it is added or subtracted, the derivative, that's 0, correct? Okay, keep those straight. But again, it's just copy derivative of the exponent. Okay, we're good? That's not, no, I did not need to hear that from you. Okay, who's good? Ish. About half of us are ish. Okay, can you do this one? Okay, and you can do sine and cosine without any of the junk in it? Okay, so we're good there. You're just having trouble dealing with these. Is that what
You take the first, like that first section, the 7, you take the first one that has
Yeah, it's x. What's the derivative of 7x? 7.
Okay.
Yeah.
You just divide by
Divide by the derivative.
You're making it too complicated, Dad. It shouldn't be so
No,
simple.
it is that simple. Let it go.
Calculus said nothing, so that would be simple, but this is.
Calculus, you can't make it complicated.
You can.
That's how we screw up all the time when we're working together, is like we make things way too complicated.
Yes, you will see. Again, here's 2 things that will help you the most. Calculus, keep it simple. You're going to see some free responses, and you're going to have like no idea what to do. And your wheels are going to be spinning, and then I'm going to tell you how to do it, and you're like, it's that easy? Yeah, it's that easy. Keep it simple, and practice, practice, practice. Okay? Gabby.
Can you tell us how to take the derivative of that so we can try it check our work?
I think you can calculate this derivative. 12/7. Copy. Right? The derivative of e is copy. Or the derivative of e is e to the x. So copy the inside. Now what's the derivative of the inside? Do they match? That's why we have to put the 7 underneath. This is the chain rule. We have to deal with that. Okay, you have time. Now you have about 20-25 minutes to work. If you still need help, we're going to keep talking. But if you want to work, you can work.
Which one is the answer for this cosine on this one, right?
Right.
Well, how come we did that? I knew my backpack else with the two cosine.
Because this is a chain rule. The derivative of sine is cosine. Copy the inside. Derivative of the inside is 2. So I was showing you why, see how these don't match?
Yeah.
I was showing you why you needed the 1/2 out front.
Oh, so there needs to be a 1/2 right here.
Here.
Okay.
Because when you do the chain rule, this puts a 2 out front. So 1/2 times 2 gets you your original.
Okay.
So yeah, 1/2. Yeah, it's, yeah.
I'm so proud of you.
Yeah.